Hi everyone, I'm Mirco and I'm going to present to you a policy gradient method for task-agnostic exploration, which is a joint work with Lorenzo and Marcello. For starters, let me frame a little bit of the context. Here we have a learning agent and a lifelong learning timeline. At some point, we assume to have a supervised phase composed of a sequence of tasks with their corresponding reward functions, each of them requiring a certain amount of exploration to find an optimal policy. These tasks might be playing tennis or driving a car. A human agent would never try to learn these tasks from scratch. Instead, he would undergo an unsupervised phase where no reward is specified, but he can still perform task-agnostic exploration of the environment, so that the resulting policy will be a starting point to efficiently learn subsequent tasks. In this work, we focus on task-agnostic exploration. Hence, we would like to learn an exploration policy to interact with the environment, which is represented by a Marco decision process. A policy induces a certain distribution over the states of the environment. Our objective is to find a policy that visits every state sufficiently often. Thus, we are interested in the entropy of the state distribution, which is defined by this expectation. And especially, we aim to find a policy maximizing the entropy function. We call it the task-agnostic exploration objective, which have been addressed in some recent works. Unfortunately, literature methods would either require a full model of the transition dynamics or a direct estimate of the state distribution. Both of these methods hardly scale to the most complex environments. Instead, we present a new algorithm, maximum-entropy policy optimization, MEPOL for short, which is based on non-parametric entropy estimation. An approach of this kind does not require to model the state distribution to have an estimate of its entropy. The underlying intuition is quite simple. If we draw a realization from the state distribution, we can speculate its entropy by looking at the spacings between samples, where an higher entropy distribution would generate widespread samples. The algorithm works as a trust region policy optimization procedure, in which we iteratively collect samples with the current policy, and we then optimize the entropy estimate to compute a policy update. This recipe allows learning task-agnostic exploration behaviors in high-dimensional environments, such as Ant. As you can notice on the left-hand side, this scenario, a random policy would not produce any significant behavior. In contrast, a policy learned with MEPOL leads to a rather meaningful exploration of the environment, even without any external supervision. Moreover, a policy of this kind is a useful starting point to solve a variety of tasks in the supervised phase, such as jumping, or walking on a straight line, or rotating from an upside-down position. If you want to know more about our algorithm and the presented results, please visit our poster at the 4th Lifelong Learning Workshop at ICML. Thank you.